Gotta get loose. Gotta get loose. All right. We warmed up. Let's talk about the Olympics. Now, the Olympics are amazing. I'm pretty sure everyone has seen at least a little bit of the Olympics. They only happen every 4 years, though. But every 4 years, you see the best people in the world doing amazing stuff. Now, what would happen if you saw them play every year? Well, I guess you can do that on some of the sports professional circuits. But then what about every day? What about if you saw them train? What about if they saw each other train and they could learn off of each other and copy each other's best moves? This happens actually in some sports, things like ice skating, where everyone goes to the same training facilities and sees just how good their competitors are getting, and they up their game and they up their game. And the next Olympics comes around and things are amazing. Well, this isn't just a metaphor. This is actually what we're doing right now within the space of reinforcement learning agents. Everyone is training. We see the results all the time, and increasingly people are training in the open. So let's get loose. This is the world of reinforcement learning today, where everyone is training on the same benchmarks in the open, and we can all see the progress. And increasingly, you don't have to be the richest player in the world. You don't have to be at the biggest lab. Increasingly, you can use open tools and train on the exact same environments that everyone else is using and build state-of-the-art models. I'm Jeff, and this is Iterative Refinement. All right, before we get to today, I want to take us back in time. I want to take us back to 2019. Now, in 2019, I am working in New York as the manager of the PyTorch team. The PyTorch team sort of grew up around the internet, but primarily lives in New York and in Menlo Park. We're organizing our second PyTorch DevCon. It's our first chance to actually bring people from the internet together to be in person. And we really want to celebrate those things going on across the entire PyTorch community with a focus on openness and those things which power research and people doing things together with open tools.
Hi, I'm Robert from Papers with Code, and I'm here to tell you about a new feature of Papers with Code that we just released today, and that is called SOTA-Bench. And the mission of SOTA-Bench is simple, and it's simply benchmark every open source model. For every open source model, we should know what the performance is, how it compares to other models, how it compares to Papers.
So that was Robert Strange, Papers with Code. He's one of the two co-founders of Papers with Code, the other being Ross Taylor. They joined us to talk about their work at Papers with Code and on SOTA-Bench. Now, all of this work was really all about helping researchers from around the industry discover the absolute latest and greatest in research, put it to work in their own research and release it back out in the wild, making it easy for people to collaborate and understand the state of progress. At the time, FAIR was extraordinarily focused on open science, and we really had a very strong belief that this organization was doing great work. And so later, I was part of a group that brought them inside, and they joined me to work as part of the PyTorch team and within FAIR to go on and do other great things, such as the Galactica model during their time at FAIR. Now, time has moved forward. It is no longer 2019. LLMs have been invented, and the space of AI and research has really changed, as well as the landscape around what is open and why. Now, since that time, Ross Taylor, one of the co-founders of Papers with Code, has left and started an entirely new company called General Reasoning. General Reasoning is probably one of the most exciting labs out there right now. They've still only released a bit of their work, but one of the most important things they just released is their OpenReward platform. And that's what we're going to use today as our framing to understand not just what's going on with this one company, but what's going on when you are trying to work with the latest environments, do RL training, and do it in the open, and work on the same open arena that everyone else is training on.
Yeah, so OpenReward is our platform. And the idea is we want it to become the place where agents get reward. So you can bring your own environments, or we have a library of over 300 environments either we've created or the community's created. We'll handle all the infrastructure, and you can come, connect to an environment, earn reward, train models, do whatever you need.
I want to show you just a little bit of what that environment looks like. So here is OpenReward. When you first log on there, you can see that they've got all of these environments set up. It's really easy to get started, and you can see a huge list of things. A big part of what I think is interesting here is that they're providing a bunch of open environments that you can find in open source already. making them easier to use.
So yeah, the OpenReward platform, I think we started working on it about 6 months ago, and then we released the platform about a month ago. So it's early days, but we're already seeing customers coming, building rewards on the platform, running agents on the platform and getting reward. And yeah, it's, as I say, early days still, but we're trying to make it interoperable with other formats. So we've got a Harbor integration now. We've integrated with Inspect, which is the AI Security Institute's eval tool. And yeah, we want to just make it, we want to play nicely with everything else and make it just the place to come for people who want to train oral agents.
So this is the OpenReward standard. It's something that the general reasoning team built. And it's used in the OpenReward platform, but it's a general purpose standard for environments. It's built on the concepts from MCP. It defines things like episodes, rewards, tool calling, so on and so forth, to give you reusable components that you can build around as an environment designer and make it available to other researchers to do their work and to potentially push up performance on your task of interest.
I think actually last week, Thomas, another one of the founders, I think he one-shotted a brand new environment with Claude Code. So we wanted to make a zebra puzzle environment, and Thomas took the OpenReward CLI, told Claude Code exactly what he wanted, and yeah, we managed to one-shot like one environment with one invocation of Claude Code.
You know, the open secret is that a lot of the things that we use for benchmarks for a long time just aren't that real of tests. They're not that hard. They're really static, and they don't actually challenge the models in the ways they need to be challenged.
So I think the current space is like very like honed in on software engineering as a task to focus on, and that makes a lot of sense because if you can automate that, then you can do a lot of things. I think the issue is that a lot of the benchmarks themselves are very procedural. So what that means is like the task might be very like well specified, saying you need to implement X, but it doesn't actually give a lot of space for the model to think in a very open-ended way. Chances are the kind of branching factor or the number of things you can actually do is not that great. And also the environment itself is like very static, right? And I think as we're getting to this world now where, yes, models can do things for longer periods of time, we actually care, a lot less about that, but a lot more about new types of capability, like, can the model adapt over time, right? To like the changing seas of the world. And also like, yeah, it's probably going to be acting in the world of other people, right? So, a market like KellyBench, for example, in essence, it's adversarial because you might be finding something that's an interesting edge, but then the market might also be finding that. So just to summarize, KellyBench is like a different type of beast. It's long horizon, it's open-ended, it's highly non-stationary. And I think as we'll talk about, models are very, very bad in this kind of setup.
So what are some of the things that actually make an environment hard, that make it challenging, worthwhile to develop intelligence upon? Well, one of the biggest things that everyone's talking about these days is long horizon, by which we mean accomplishing things that take a lot of steps, which you have to work on many, many times. Another is coordination, having multiple agents accomplish some larger task together. A lot of times coordination is done in a very unprincipled fashion. And so I often think of principled coordination as a really key goal. Are you in fact knowing what you're intending to communicate in a way that doesn't result in you just talking past each other inside the LLM? I want to show you some of this work on KellyBench from the general reasoning team. This is a model around sports betting, specifically on the English Premier League. What I find really interesting here is that it starts off with a property I always really want to see in a good benchmark, which is that it's provably tractable, but mostly hard. That we don't actually have models that do really well at this automagically without any effort at all. And so you can see all the greatest models in the world basically crash to losing a bunch of money betting on football. Surprise.
One of the things people underappreciate, and the models underappreciate this, is like your first task in this environment isn't actually to make money, it's to avoid ruin, right? So I think the models, they have this attitude, they're a bit like kind of turkeys, like starting in January the 1st, and they're having a great time until like, Christmas or Thanksgiving comes around, right? And they get their head chopped off. So I think that, maybe Thomas can talk about this, but I think there's like a broader kind of like situational awareness problem. And we see this like in all kinds of bit of the tasks. Like, as an example, like we said, just like risk management is like your first job. But then B, like, yeah, you're in this dynamic environment, right? So, well, you're predicting for 2023, what you're going to be back testing on.
We perfectly describe the like Kelly criteria, but then actually implementing it during the rollout, it like struggles to. So there's a bit of a gap between like the actions of what the models, know and what they can actually do over a long horizon.
Yeah, so to Kip's point from before, awareness versus action gap is the first obvious blind spot. We saw repeatedly behavior from the models where they would say, actually great ideas, you know, like, oh, I'm going to do fractional Kelly staking or something like this. And then they would just never actually do it. Or things like, oh, I noticed that my model is underperforming in this way, and then make no changes. This type of behavior is probably the lowest hanging fruit in terms of long horizon performance.
There's this really interesting balance here in being able to understand what generalizes and what doesn't when you train in this manner, because things which look good in training oftentimes don't stand up to the real world of competition. And this move towards more realistic environments gives us that understanding of where we're making progress and where we're still sort of playing artificial games that don't give us all the progress we really want. So last week, I joined the general reasoning team and a big chunk of the community here in East London in Shoreditch to judge the Complex Worlds Hackathon. It's the first hackathon that the general reasoning team has hosted. And it was really an incredible experience to see the huge diversity of thought within the London open source and AI research community and how they would put to use really all of the substantial capabilities that come out of the box with OpenReward.
So we wanted to organize the Complex Worlds Hackathon to get some awareness out there of what we're building, and also to just tap into the ecosystem in London and see what kind of ideas for these like long horizon environments people are having. And it's been good. Like, we had a ton of interest. I think a lot of people, recognize that this is an exciting place to be working. And yeah, there's been a real range of stuff that people are working on. I was just having a chat now with someone who is looking at formal verification, and they're trying to build environments for formal verification. It was quite interesting. At the same time, there's someone else here who is trying to build an environment that simulates elderly care. So at the moment, it's all simulated. But yeah, it's a long horizon, multi-turn environment in which an agent has to basically, given diagnostic information at sort of stages in time, it has to make clinical decisions and make care decisions and sort of get feedback based on those responses.
There's two really related messages I tried to land in my discussions with the competitors at the hackathon that I think are really key for anyone who's building this space these days. The first is that there is a special magic to building in the open because you get to learn from each other and you get to contribute to that progress. It creates a collective flywheel of progress that we all learn from each other. And you can really see that in a room that has some intellectual diversity, which isn't always easy to find. AI research is very much prone to following fashions and getting into a monoculture. But I was extraordinarily impressed by the diversity of thought within the room at that hackathon. And what that results is people really learning a lot of different things from each other. And the second message I really tried to underline at this event that I think really comes through in their work is to really do remarkable work, you must be doing that work in a domain in which it can be remarked upon. That is, if you're really actually trying to get the benefits of having the better idea, of pushing forward the state of the art, you have to be doing it in a place where it is legible, where people can see it. I'm stealing this shamelessly from Cal Newport, who said it better in blog posts, books, podcasts. So let's talk a little bit about our winners of the hackathon, Khalid and Julie. Now, they came together in a really interesting project, and I really wanted to share some of their story with you so that you could see the faces and the people behind these projects, why they're motivated to do this work, how they do this work, and what gets them excited.
Cool. So I left my last company a few months ago, took a bit of a break, and then I was sort of exploring what next or what project I want to undertake next. Explored various areas, but one thing that like really stuck out was sort of AI benchmarking and where kind of the future of model development is going. After Meta acquired Scale, then there's been kind of a lack of like a really good, robust benchmark out there. And I thought RL environments are sort of like a perfect thing. I was chatting with a friend who's at EF, and he was just like, dude, like we're co-hosting this event that's like right up your alley. Sent me the link, came across it, but like, wow, Bully RJ, this is like super cool. Sounds awesome. I need to go here. And texted Julie, and then she was happy to sort of like join as well.
Because OpenReward is so incredibly new, the vast majority of competitors at this hackathon were using the platform for the absolute first time. So we're really seeing this sort of first user experience and the tremendous productivity that comes from thoughtful platform design that takes into account all of the common abstractions that people need when building environments for reinforcement learning.
Yeah, so for me, I first encountered OpenReward just the night before the hackathon. And on the platform, I discovered my own project, which is Catan environment. I found it quite surprising because I didn't know that it's on the platform before. And I found it's a really good platform to group all different kinds of environments together, because for Catan environment, we use this hybrid format. But another environment use a different format. It is very difficult for developer to just go and use them all at once. So with this platform, we can skip the boring part of setting up everything and just go straight into training an agent with the RL environments.
Sure. So, firstly, I'm sort of obsessed with games. I co-founder and run a community called techgames.xyz, where we basically host a bunch of startup founders, operators, and investors, and we play board games together. And sort of like some very, very smart people historically love games. It's sort of like pattern matching, if you will. So like Demis Hausbis is a very famous example, was a sort of chess prodigy, and then later Go, and then he's like 6-time diplomacy world champion. And then sort of like there's a wide range. Steve Wozniak with Nintendo, Bill Gates is one of the top 20, I believe, bridge players in the US. And Warren Buffett used to be up there as well. And way back in 1950s, and I only found it out recently, but Alan Turing sort of like hypothesized that a really good way to teach machine intelligence would be to simulate a child's mind. And he said that, and then he later sort of said like children learn through play. And he created a sort of like chess competition platformish thing as a measure of intelligence. And so he thought board games specifically was also like a really good way of sort of like interacting with intelligence and assessing intelligence and training it. Essentially games are a very good simulation of the real world with some very nice abstractions.
Personally, I was very excited to see this team working with diplomacy and working with diplomacy in a hackathon. You see, years ago, back again at Facebook and FAIR, I was the manager for a team that worked on a project on diplomacy. The model that resulted is known as CICERO and was really the first superhuman player of diplomacy.
One of the reasons why this work matters to me is it's really showing the world what AI is capable of doing today. I think there was this perception that an AI could never have the social skills of a human in a game like this, could never succeed in a game like this because it was just too human of a game. And what we're seeing here is that an AI can do things that are not just, computing numbers and multiplying digits. It can actually like talk to people and work with them, and there's a lot we can build on top of that.
One thing that impressed me about CICERO's dialogue capabilities is that it's able to hold conversations with people for a long time in a very fluent way, 6 different conversations simultaneously, which is actually very different to other dialogue settings people have explored before. It's human-like, it's strategic, it's frustrating sometimes, it's persuasive.
But even more impressively for me, it takes a strategic understanding of the game. And I mean, I think that's just amazing that your team has collectively come up with an agent that can deliver that. I think that exceeds anything I ever expected.
So for those of you who maybe don't have an understanding of what the inside of a major lab used to look like, at the time of the diplomacy project at FAIR, we really had some incredibly smart people consuming huge amount of resources, spending directly on compute, on competing in the open, on hiring experts, and working for years just to get that one very exciting outcome, that this world of communicating with humans and forming alliances cooperatively was in fact going to be a solvable problem. It took years. We needed to employ a professional world champion diplomacy player winner to be able to address this problem at all and to get interesting results and to actually be able to publish something that was meaningful that advanced the state of science. Now this is so well understood that we as a community have come around the power of games to push forward this research. This is now a hackathon project. It's actually a subset of a hackathon project, which I think is amazing and incredibly exciting.
Okay, cool. So essentially what we found was that like with Catan, we did sort of steer the models in a sense to do this, but not all models kind of like took the bait, if you will. Then when we enable chat between agents alongside trading, so they can send a message with the proposed trade versus just the proposed trade, then some models act in sort of dishonest or devious ways where they will claim to have a sort of sob story, like, I'm a single mom with 3 kids and I'm going to be homeless. I really need this wood to build a house so that I can live. And they'll propose the trade and they'll have higher acceptance rates than when they don't send a message like that, which is sort of like very interesting. But then also, obviously, an LLM cannot be a single mother, but it kind of like presented that. And then the LLM on the other side kind of took that in, parsed it. We didn't have enough time to test whether any models could identify it, but like all the few examples we did pick up, then none of the other models identified, hey, this model is being dishonest. It was just like, oh yeah, I am sort of like trained in a position where I should be accepting this trade. So they just like do the trade.
I think it's really interesting to observe that in pure LLM gameplay, we're seeing a different result than what we actually saw within the CICERO project. So inside the CICERO project, what we observed was that the best strategy was actually to be very trustworthy, to be very open and honest and collaborative. But that some LLMs are finding it very successful to be deceptive when communicating exclusively with other LLMs. And I think that speaks to what are some of the nuances in research like this around multi-agent coordination and whether we're really talking about artificial humans or true natural humans in our agent modeling.
Yep, so we did 2 sets of experiments on the Lemonade game we designed. So the first set is on short runs, so it's only runs of 30 steps. And we find that with like small number of steps, small models can perform even better than large models. So I think we're experimenting using GPT 5.4 mini, and it's doing better than Claude Sonnet and also GPT 5.4. But if we extend the turns number to 300, then obviously like the large models beginning to show their depth of reasoning and planning strategically and outperform small models by a large margin.
And kind of like touching on what Julie said earlier about like long horizon versus short horizon, essentially what we found was that like the larger models were smart enough to make what seemed like bad decisions in the short term, but long term, the move they made, like sort of like 30, 40 steps back, enabled them to do this other move, kind of like 40 moves in the future, which pushed them ahead of the smaller models. So that was quite interesting because even as a human, when I was like first running through the replay and I was like at 30, 40 steps, I was like, these small models are like kicking ass and they're like sort of like beating the bigger models. And then a few steps later and you're like, oh wait, that's why the big model did that.
Yeah, my favorite game is Overcooked because I like the UI layout of it, and also it has a lot of different maps, and also it is a very stressful game. Like you need to make a lot of order in a very short time, and like I kind of like the stress.
So I think there's one thing that's front of mind for us at the moment, and we've said it before. It's long horizon tasks. I think a great deal of progress has been made in math environments and obviously coding as well, which is really incredibly useful, and I think is an obvious first candidate for these sort of systems. But I think what we're finding is those sort of one-shot tasks where the distribution of data that the model sees is quite static, like doesn't necessarily enable the models to perform these like long horizon tasks really well. So I think a big thing for us is this focus on, and you've seen this a little bit with our KellyBench paper. So our KellyBench paper, if you haven't seen it, was the agent is tasked with developing a systematic betting strategy to try and win as much money as possible betting on the English Premier League football series. And the interesting thing about that is the data distribution changes through time. You might have a systematic strategy that works in one season, but by the time the next season comes around, those features no longer make money. So the agent has to adapt through time in order to make money because it's pretty competitive and the odds are quite stacked against it. And I think one thing we found in that paper is that models at the moment are really bad at that. And our suspicion is because no one at the moment is really training these models to kind of evolve and adapt through time in these kind of long horizon, these shifting distribution tasks. So I think for us, that's a really big focus. we're spending a lot of time internally thinking about how we can build environments to facilitate that. And yeah, hopefully we'll see some other hackathon today.
Yes, so for me, I think it will be, is it the first one on the bicycle route one? I think that one is quite interesting because for most of the environment, it is more on software engineering side or like games related. But for that one, it is actually benchmarking a problem in the physical world. So that really catches my attention.
So I think what a benchmark like KellyBench really shows us is that good tasks to train on, good environments, they are educationally hard, and it's non-trivial to surmount them because they're really getting very close to those things which we as humans do uniquely well.
A little bit similar to what Thomas sort of said. It's more towards the creativity side. Like, I think we have quite a clear path to make models better at programming. Like, this is fairly defined. You throw more environments at it, you define what you want it to do, and it just does get better.
So I think as a team, and maybe you guys can disagree, like I don't think we're bearish on AI models at all. I think journalists, for example, are a lot more bearish than we are. But I think it's more just like a shift of focus is needed a bit towards these tasks where we can actually test these capabilities which matter for kind of real world deployment.
So I want to give us just a beat to reason about the history of what has been AI research, our data sets, and our resources. So back in the day, most of the best research in the world was only being done at labs that really had the substantial resources to put into huge data sets, huge amounts of compute, and really having quite unique technologies that other people didn't have. And so this is places like FAIR, like DeepMind, like OpenAI. These days, the world's quite different. You can do amazing work with purely open tools, with purely open data sets, and purely open environments. To me, that is incredibly encouraging for the diversity of work that is likely to emerge from that broad access to the range of the best tools.
Our goal is to make agentic RL as simple as possible and to bring the marginal cost of the experience to zero.
I often think about deep learning, right? Deep learning didn't work for like a long period of time, but then people pursued, right? Now, they weren't just following like a clear objective to do well, otherwise they do like some other technique, but they saw something very like long-term, like this is the way it has to be, right? And I think, yeah, KellyBench is like, in a weird way, like an early example of that, right? And that is so open-ended that, you might commit to approach for like, however many tool calls and it might not work for a long period of time, but you just have like some sense for this has to work, right? So, yeah.
I really agree with Ross here. I think this is something that a lot of us at FAIR strongly believed was that there was a lesson to be learned from Jan and the rest of the deep learning tribes' journey through the woods, that their perseverance through the world's skepticism about the potential of deep learning is itself a lesson to apply yourself to hard problems, to persist in directions for which you have a principled and motivated reason to progress forward. So I want to connect us back to the beginning again. We're in the arena. We're at the Olympics. People are watching us. They're watching us compete. They're watching us train. We're watching our competitors, and we're learning from each other. What this means is that we can pick up the advances so much faster. We can learn from each other, and we can do better work as a group. None of us are as smart as all of us together. I think that's the power of community, and that's specifically the power of open collaboration. I'm incredibly excited to see this progress, both from general reasoning with OpenReward, but generally the trend line of seeing more and more work land in the open that is actually composable into giving a broader range of people and organizations the ability to compete on a level playing field and develop the artificial intelligence capabilities and power the next wave of innovation. That to me is incredibly exciting and incredibly motivating. It makes me want to get up every morning and walk into the arena. I've been Jeff. This is Iterative Refinement. See you on the internet.